Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on Mathematics Grade 11, Equations and Inequalities. And this is video 3 of a 4-part video series on Equations and Inequalities. And this question comes from the November 2021 Paper 1, the Gauteng Province Department of Basic Education. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 4 and more videos we upload in the future. We have a lot to cover, so let's start. Question 1 goes, given p equals 2 in bracket x plus 2 in bracket 2x minus 1 all over 3 minus x. Determine the values of x for which p is 1.1.1 equal to 0, and then the next one when it is undefined. P is equal to 0 when this one is going to be easy. P is 0 when P equals to 0. This is the situation. This whole thing equals to 0. So that will be in bracket x plus 2. And then 2x minus 1 all over 3 minus x. This is equal to, okay, let's make it black. Okay, this is equal to 0. Now what you do is you cross multiply. So therefore, this will be equals to 0. Now you solve like you would any equation. So that will be x plus 2 equals to 0 or 2x minus 1 equals to 0. Never skip this step. This is where a lot of people make silly mistakes. So we've got x plus 2 equals 2. So that will be, therefore, x equals to negative 2. Or 2x equals to negative 1. Or is it negative 1? Let's see. No, it's positive 1. Or x equals to 1 over 2. And that is the answer there. Next, what happens when, okay, what are the values of x for when p is undefined? P is undefined when the denominator, which is 3 minus x, is 0. Meaning that therefore, when 3 equals to x, or when x equals to 3, and that's how you answer that question. Next question. 1.2 is solved for x. Let me show you. 1.2 is solved for x, so we're looking at 1.2.1. 1.2.1 will be 2x squared minus 3x minus 4 equals to 0. We're solving this correct to 2 decimal places. Now, whenever they say to you, solve anything correct to 2 decimal places, that means it's a sign that you will be needing the quadratic formula, because whatever you are trying to solve is not going to be easily factorized. So now let's find a, b, and c. A is the coefficient of x squared, which is 2. B is the coefficient of x, which is negative 3 with the sign. And then c is the constant, which is negative 4. You should know how to work the formula by now. So this should not be new. It should be very easy for you to navigate, because this is easy. All over 2a. Now here you must make sure that you substitute correctly, because you get marks for correct substitution. Don't work anything out, just substitute raw as it is. Now I've got b is negative 3, that will be all squared minus 4. A is 2. C is negative 4. Okay, all over 2 times a. 2 times 2. That is our a. Now you take out a calculator. The calculator work. This is where some people get it wrong, so please make sure that you understand and you work your calculator very well. So step number 1, you go common fraction button, and then you go minus -3. Okay, let's take this up. Minus -3 minus -3 plus square root of, all right, open bracket, -3 all squared minus 4 open bracket. A is 2, then C is -4, downward arrow 2 open bracket 2, because that's what it is. All right, and the answer gives us correct to decimal, that is 2,35. 2,35, that's the first one. Or to find the next one, all you do is you go to the plus before the square root sign, delete that and replace that by a negative, and it will give you -0, sorry, that was -0,85. Sorry about that. -0,85, and that's your answer. Next question goes 1.2.2. This is an inequality. Solve for x, and this is the inequality. All right, solve for x when this is the case. So what you do is you take everything to the left hand side. We're going to expand and rearrange, refactorize. So make sure that you have everything ready. All right, minus x. And then we take the 4 to the left hand side, it becomes, and the inequality stays exactly the same. So expand, that is 6x minus 2x squared plus 9 minus 3x minus 4, that is greater than 0. Add like terms, minus 2x squared, 6x minus 3x, that is plus 3x, 9 minus 4, that is 5, greater than 0. Now you divide throughout by negative. All right, you can solve it the way it is, or you can divide through. Okay, so this is, all right, so yeah, you can solve it the way it is, or you can divide throughout by negative, so it is easier for you to, so but whenever you divide an inequality or multiply an inequality by negative, this inequality sign changes direction. It looks the other way around, and therefore now this is, sorry about that, that is -3x, that should be less than. And now our a is equals to, all right, let's factorize. Our a is positive now. Keep that in mind. 5 and 1, okay, now we go 1 and 5 plus 2 minus 5, yeah, that is less than 0. Okay, here are the critical values. Critical values are those that would be roots, but they're not roots because this is an inequality, not an equation. Equals to 0, therefore 2x equals to 5. Therefore, x equals to 5/2. That's the first critical value. The second critical value comes from the other factor. Therefore, x equals to -1. Now we've got these critical values, and let's use two scenarios. Okay, the first scenario we're going to use is where we have a positive a. In other words, this scenario when it's less than, okay, Option 1 or case 1, this is when A is positive, all right, meaning that the arms look up. This A is positive, it's 2 in this case. The arms look up, and we're looking for where this lies below the x-axis, because it's when it is 0. We're looking for where it lies below the x-axis. It does not include the endpoint. Now this is where, all right, this is where it lies below the x-axis. All right, it lies below the x-axis. What are the critical values? The critical values are -1 and 5/2. Put them like you order them like it will be a number line. So therefore, this 2x minus 3x, 2x minus 3x minus 5, 2x squared minus 3x minus 5 is less than 0 when our x is between 5/2 and -1 and not including the endpoints. That is case or option 1. Case number 2 or scenario 2. Scenario 2 is when we take these critical values, right, and the coefficient A is negative, and it's equals to -2 in this case. If it's negative, that means that the arms look down. Now for this case, we're looking for x when, this is the case, we're looking for x when this is above the x-axis. Critical values remain the same. When does it lie above the x-axis? Okay, let's change color to red. Okay, here x is greater than, all right, when minus 2x squared plus 3x plus 5 is greater than 0 when x is between the endpoints. So these are the two options. You can use whichever scenario you prefer. That's how you solve the inequality. Next question, 1.2.3. Solve for x when this is the case. Now, whenever you have this scenario of a solid equation, make sure that you take everything that is not inside the square root sign to the right hand side or the left hand side, depending on what you are dealing with. All right, I'm trying to, okay, all squared. Okay, so let's take that x to the right hand side, so it becomes 4 minus x. Next step, you square both sides to get rid of the square root sign. But what you do to the right hand side, you must do to the left hand side, and vice versa. Now when we square the left hand side, all we do is you remove the square root sign. When you square the right hand side, that's squaring a binomial. When you square a binomial, it will be the first term squared plus 2 times the product of the terms with the signs plus the square of the last term with the sign. Now that gives us x plus 2 equals to 16 minus 8x plus x squared. Take everything from the left hand side to the right hand side. So we end up with a quadratic equation minus x minus 2. Don't forget to change the sign when they cross the border. So that's x squared. Let's add like terms. Minus 8 minus 1, that is minus 9x. 16 minus 2, that is 14. Now let's factorize x and x. Now here are the factors of 14. 7 times 2. Now the combination that gives us 9 is this combination. So we have 7 and 2. And both of them will be negative, because when you multiply them together they give you a positive 14, and when you add them together they give you negative 9. Now the step I always say do not skip, so that will be x minus 2 equals to 0, x minus 2 equals to 0, or x minus 7 equals to 0. Therefore x equals to 2 or x equals to 7. Let's check. Always check, because squaring introduces roots that may not be, or solutions that may not be part of the final solution. So we need to make sure that we eliminate those in case we do have such a scenario. So that is okay. We're checking x equals to 7. Alright, for x equals to 2, we go left hand side, substitute 2 wherever there is x. That will be the square root of 2 plus 2 plus 2. Notice I'm putting those that are the factorize the substitution in brackets, so you can see what we're substituting and what we're not substituting. Square root of 2 is 2, 2 plus 2 is 4. And that is equals to the right hand side, yes. Therefore, x equals to 2 is a valid solution, because the left hand side is equal to the right hand side. This is a valid solution. Valid solution. Now let's look at the other one. Okay. Left hand side equals to square root of 7 plus 2 plus 2. Okay. Which is square root of 9 plus 2. Square root of 9 is 3 plus 2. No, sorry, plus 7. Sorry, made a mistake there. With substitution, we're substituting. Alright, so this is 2 plus 7. 3 plus 7, that gives us 10. Sorry about that. Silly mistake. See, these are the type of, and this is not equal to the right hand side, because the right hand side is equals to 4, right there. Therefore, it means that this is not a valid solution. Okay, therefore, x equals to 7 is not a solution. And therefore, this means, therefore, x equals to 2 is the only solution. Always write the final conclusion. Next, solve for x, you've got an exponential equation here. So what you do whenever you've got this type of equations where the variable is the exponent, make sure that you break it up. So let's do that. So that will be 2 to the power of 2x times 2 to the power of 1. That's how we break it up. Minus 3 in bracket 2 to the power of 2x times 2 to the power of negative 1 plus 2 to the power of 2 all raised to the power of x plus 12. Next, we apply the rules of exponents. So that is 2 times 2 to the power of x, 2x, minus 3 in brackets 2 to the power of 2x over 1 over 2 to the power of 1. That's taking this to the bottom so that we can have a positive exponent. So that is 2 to the power of 2x. So when you raise the power to another power, that will, we multiply the exponents, and that gives us to the power of 2x equals to 12. Now to make life easier, let 2 to the power of x, 2x, because look, if you look at this, the 2 to the power of x is a recurring theme here. We've got a common factor. So let that be equal to k. All right. Let 2 to the power of x, 2x, let k equals to 2 to the power of 2x. Therefore, 2 times k, right, minus 3 times k over 2. So wherever you see 2 to the power of 2x, replace that with k. Here's another k over here, equals to 12. Using the k method makes it easier to work it out. So this 2k plus k, that is 3k. 3k minus 3k over 2 equals to 12. We've got an LCD here. So this is a rational equation. LCD equals to 2. Now what you do is you multiply throughout by that LCD. So that will be 2 times 3k minus 2 times 3k over 2 equals to 2 times 12. Both the left hand side and the right hand side are multiplied out. Notice that the 2's cancel out over here, and that leaves us with 6k minus 3k. Therefore, 6k minus 3k, 6k minus 3k equals to 24. 6 minus 3, that is 3. Now divide both sides by 3. That will give us 8. Meaning that therefore now we revert back to 2 to the power of 2x. Remember, we're not solving for k, we're solving for x. So that will be 2 to the power of 2x equals to 8. 8 can be written as a power of 2, and that is equals to 2 to the power of 3. Now we've got powers of the same base equal. All we do is we equate the exponents. Solve like you would any equation. Therefore, x equals 2, divide both sides by 2. You can check, okay, just to make sure that it's all above board. It's not a difficult one to do. You can even take your calculator. Okay, left hand side equals to, wherever there is x, you put 3 over 2. So that will be 2 to the power of 2, 3 over 2, plus 1. Okay, and then minus 2, minus 3, 2 to the power of 2, 3 over 2, minus 1, plus 4 to the power of x plus 4 to the power of 3 over 2, which is equals to, okay, notice that the 2's cancel out here. Over here also. Alright, and here 4 can be written as 2 to the power of 3, so 2 to the power of 2, so that is, the 2's also cancel here. So that is 2 squared times 2 to the power of 2. Alright, so they cancel out. That leaves us with 2 to the power of 3. So that is 2 to the power of 3 plus 1 minus 3 times 2 to the power of 3 minus 1 plus 2 to the power of 3. That gives us 2 to the power of 4 minus 3 times 2 to the power of 2, which is 4, plus 2 to the power of 3, which is 8. So that is 16 minus 3 times 4, that is 12, plus 8. 16 minus 12 plus 8 equals to 16 minus 12 plus 8 equals to 12, which is equals to the right hand side, meaning that x equals to 3 over 2 is the correct solution. So we've shown that. You don't have to check with this one because we did not introduce anything, but it shows that that is correct. 1.3 goes, given f of x equals to x squared plus 8x plus 16, calculate f of 2. That one is very easy. You just substitute f of 2 equals to wherever there is x, you put 2. So that will be 2 all squared plus 8 times 2 plus 16. Take out a calculator and just quickly calculate that. So that will be 2 squared plus 8 times 2 plus 16. And that gives us 36. So that is equals to 36. And we're good. We're done here. Next, determine the values of x for which f of x is greater than 0. So we're dealing with the inequality now. 1.3.2. F of x is greater than 0. Therefore, x squared plus 8x plus 16 is greater than 0. Alright, let's factorize so we can find what the critical values are. Alright, the factors of 16. The combination that gives us 8 in the middle when we add is 4 times 4, so that's the one we use. 4 and 4 plus and plus. And this can therefore be expressed as that all squared is greater than 0. Alright, now the critical values, it's only one. Obviously, you can see that. Critical values. We've got only one in this case. X plus 4 equals to 0. Therefore, x equals to negative 4. That's what it is. Now, a is 1. A equals to 1, which is positive. So meaning that our arms look up. The arms of the parabola look up. Now when the arms look up, alright, and we only have one critical value, it means that the equation, the graph touches only at that. That's what it means. So we're going to put a, alright, let me put a circle. There we go. Let me make it green so you can see. So that is negative 4 there. That's our critical value. Now we're looking for where this is. greater than 0, meaning that where the graph lies above the x-axis, the graph lies above the x-axis here. Let's make this purple or yellow. All right, this is where, except for when x equals to -4, this is where the graph lies above the x-axis. At x equals to 4, it lies exactly at 0. It's not above the x-axis, it's on the x-axis. All right, so therefore this is greater than 0. Therefore f of x is greater than 0. F of x is greater than 0 when x is an element of real numbers for all except for when x is -4. Except for when x is -4. Next question. Solve for x and y. This is the simultaneous equation. All right. Okay, looks like these questions are switched about, but that's fine. Let y minus 2x plus 1, that's what you do. Assign them to numbers so they are easier to, and the second one be equals to equation 2 plus 3x minus 10. This is equation 2. All right, so now from equation 1, the goal is to express any of the equations, the simplest, as one variable in terms of the other. In this case, we're going to have it as y equals to y in terms of x. So that will be y equals to, take everything to the right hand side, 2x minus 1. And we'll call that equation 3. All right, now substitute into 2 into equation 2. Okay, when we substitute 3 into equation 2, wherever there is y, you put 2x minus 1. So that will be x, 2x minus 1. Y, 2x minus 1. Okay, and then equals to 2y. No. Yeah, 2x minus 1 equals to 2x minus 1 plus x squared plus 3x minus 10 plus 3x minus 10. All right, so now you expand. Let's expand. 2x squared minus x equals to 4x minus 2 plus x squared plus 3x minus 10. Now you take everything to the left hand side. Alright, so that becomes 2x squared, okay, minus x squared, and then minus x minus 4x, and then minus 3x, we're taking the x's, and then the numbers would be 2 plus 10 equals to 0. All right, the x squared give us 1x squared, and then the x's, that's -1, -4, -3 minus 8x. Okay, so that's x squared minus 8x x squared minus 8 squared plus 12. equals to 0. Factorize x and x equals to 0. Alright, so that's 12 times 1, 6 times 2, 4 times 3. Alright, the combination that gives us 8 is 6 and 2. So that is 6 and 2. Minus and minus. Therefore, x minus 2 equals to 0. Never skip this step, I always say. I'm not gonna get tired of saying this because this is where a lot of people make silly mistakes and then get the whole answer wrong. Therefore, x equals to 6. Alright, so now what we do is we substitute into 3. Alright, substitute into 3. Into equation 3. Okay, for x equals to 2, y will be equals to, let's see, 2 times 2 minus 1, which is equals to 4 minus 1, which is equals to 3. And then for the other one, okay, let's make it yellow. For the other one, that will be for when x equals to 6. Alright, y will be equals to 2 times 6 minus 1, which is 12, minus 1, which is 11. Alright. Therefore, it means x equals to, y equals to 3, x equals to 2, or x equals 2 and y equals to 11. X equals to what? 6 and y equals to 11. You can check. How do you check? You take out a calculator. Use equation number 1 to check if x equals to 2 gives us y equals to 3. We can do that. Okay, so for y equals to 3 and x equals to 2, that is in equation 1. We want to see if the left hand side equals to the right hand side. So it will be y, wherever there is y, we put 3. Minus 2 times 2 plus 1. Okay, that gives us what? That is equals to 3 plus 4. 3 minus 4. 3 minus 4 plus 1, which is equals to 0. 4 plus 4 minus 4. So yes, it checks out. Let's check the other one. Let's check this using equation 2. That will be, left hand side will be x times y, which is 66. Let's check the right hand side if it gives us 66. So that will be 2 times 11, because that's y, plus 6 all squared, plus 3 times 6, minus 10. Okay, let's use a calculator to check if it gives us 66. Alright, so the calculator goes 2 times 11, 2 times 11, alright, 2 times 11 plus 6 squared, plus 6 squared, okay, plus 3 times 6, plus 3 times 6, minus 10. And that gives us 66, so that checks out. Equals to the right hand side, so that checks out. Therefore, x equals to 2 and y equals to 3, or x equals to 6 and y equals to 11 is the solution. Next. Alright, this one is next. This, I believe, is the last question. For any real value of p, prove that the roots of this are non-real. Now, okay, we know that roots are non-real. Roots are non-real when delta is equals to negative. When delta, which is b squared minus 4ac is negative 1. Okay, let's see if that delta is indeed negative for all real values of it. So what we do is we take everything to the left hand side. Xp all squared minus 2x in bracket p minus x equals to 0. Expand and then arrange in terms of the coefficients of x squared and all that. So that's xp, that gives us p squared x squared plus 3 minus, okay, so that is minus 2px and then plus 2x squared equals to 0. Alright, so now we get all the x squared together, so that will be p squared plus 2 or x squared minus 2px plus 3 equals to 0. Now the coefficient of x squared will give us a equals to this p squared plus 2. And then b is equals to negative 2p. b equals to the coefficient of x, so that's negative 2p. And then the c is the constant, which is 3. Alright, for AC, delta equals to b squared minus 4ac. And in this case, it's equals to b is minus 4. A is p squared plus 2. And then C is 3. Alright, which is equals to 4p squared that is 4p squared this is 4p squared minus 12p squared minus 12p squared plus 24 minus 24, sorry, minus 24. Okay, let's add like terms. 4 minus 12, that is what? 8. Negative 8p squared minus 24. Alright, now let's analyze this. For all real values of p, p squared is always positive or greater than 0. Right? For all real values of p, because whatever p is, when we square it, it will be positive. For all real values of p, for all real values of p. Alright, so this is always positive, meaning that therefore negative 8p squared will always be negative or less than. Okay. is, okay, negative or 0 or negative, okay? If p is 0, then it will be 0. And then we we know that also negative 24 is 0, is negative, less than 0. If this is positive, meaning making this negative, right, that means therefore negative 8p squared minus 24 will be negative, will be less than 0. All right, making it negative. Therefore, delta is less than 0, meaning negative, meaning that therefore the roots are non-real because delta is negative. The roots are non-real for all real values of p. Real values of p. And this is where we end this paper. It's the last of the question. And thank you so much for watching. I'll see you in the next video.